Hello folks and welcome to my birthday live stream. Today is my birthday. Thanks for all the well wishes folks. And I am really excited to be here once again and use this day to walk through SwiftUI There we go. As you can see, it all worked from scratch, a complete SwiftUI project, all working correctly and smoothly, which is really, really nice. I do this on my birthday specifically because I'm raising money for an important charity local to me, which helps folks experiencing homelessness this winter, and also folks who have suffered domestic abuse. They do incredible work, and so I am raising money for them. If you look on the stream, you can hopefully see bit.ly/SwiftUI22. That's the link. If you want to do a bit of donation, please do. Any amount of money in that pot is very, very welcome. Okay, this time we are again building a SwiftUI project from scratch as we go through, but with two important twists this time. First, we're building for macOS. And second, we're building a game. So two very different things, but hopefully you'll enjoy it and learn a lot along the way. It'll be great fun. To follow along, I'm using Xcode 14.1 here, only because I know a lot of folks won't have 14.2 available yet, but it was designed 14.1, 14.2 will both work great. I've written the code specifically to work on macOS Monterey, but when there are Ventura changes, I'll tell you about them. There's two places I recommend you add different code for Ventura. I'll tell you what they are when we hit those. But it does work on 14.1 and Monterey. And if you want to go, Monterey Big Sur, I've lost track now. Anyway, hopefully by now you're on Ventura anyway. But if you aren't, it'll work on macOS 12 as well. And of course, if you're here live, please do ask questions. Get involved. I'd love to hear folks who have suggestions or tips along the way to make the game better as we progress. It's a collaborative idea. We can work through it and find some great things together. Anyway, that's the link to go ahead and donate if you want to. Your name will appear on the screen, by the way, if you donate, so please do. The name in the video for ever and ever and ever. Someone asks, will the stream be available later on? Yes, it'll be available on YouTube forever and ever, hopefully, or at least until YouTube dies in the far, far future. So it's online to watch as a replay or rewind or whatever you want to in the future. Anyway, let's begin. I'm going to go ahead and launch Xcode here and choose create a new Xcode project. And then over here, choose macOS and choose app like this. Now, the game we're going to be making will be familiar to folks. My brother calls this a deep cut. Familiar folks who've read my book, Hacking with tvOS. I think it's the least popular of my Hacking with series. iOS, macOS, watchOS, and tvOS. tvOS sadly did not get much love. But it's a book as a game project in there I like very much. And I've ported that to SwiftUI for this stream. So hopefully not many folks have seen it so far, so we'll see. And it's called BioBlitz. So my product name, I'll enter BioBlitz, then press next, and then create. Another guy says, did it take long to brief your dogs? No, my dogs are downstairs currently barking at the front door. I'm not quite sure why. That's their favorite thing to do. Anyway, a new macOS project using the app template called BioBlitz. Now I'm going to hide the inspector area and the canvas area so it makes maximum space available for Xcode, only because otherwise you see a lot of more line wrapping and stuff, which isn't very nice. So this clears most of the space for our layout, which is great. We're going to start off with something really simple. Just a big grid of information on the screen with not a lot in there, just a placeholder so you can kind of see roughly how the screen will eventually look like when it's finished. So in our content view body here, I'm going to replace that with a VStack. Inside there will be a HStack containing at the top the scores and title of our game. So we'll say text green 0. By default, it's just hard code a 0 score for now. Then a spacer. Then the text of BioBlitz, our game name. Then another spacer, and then a text saying red 0, like that. So our scores are at the top like that. And I'll make these things all appear nice and chunky so you occupy some good space on the screen. So I'll say that whole HStack has a font with a system size of 36 with a weight of black. V Silverstein says, are there any form animations in the application? There's a small animation, but not a lot, no. You'll see. It's more about timing than animation. So that's our top bar. Score, title, score. But below that H stack, inside the V stack, will be our main grid the player has to control. Now in this game, they're going to have all these little bacteria on the screen, and they've got to try and turn them around to infect the whole screen and hopefully conquer all the other players' bacteria. That's the goal of the game. So inside that VStack, add another VStack for that grid we're working with. If you are using Ventura only here, not older versions of macOS, you could use a grid view here. I am targeting both 12 and 13, so I'll use a VStack with HTAGs inside of it. Like this, and then inside there will be a for each 0 to 11. That's how many rows we have. ID of self with a row coming in. Fernando wants me to do the whole thing first. I haven't got that pre-prepared, Fernando. It's my birthday. I have other things to do today. I've been out with my kids today, having a nice day. So no, I don't have that available to hand. Sorry. Next up, we have that's all our rows in place. For each row will be a horizontal stack of those bacteria. So I'll do a for each 0 to 22 columns. ID of self, with that column coming in, and just the text of X. That's we'll place an actual cell shortly, once we're further down the line. Now for this whole thing, to make sure it's sized correctly on the screen, I'm going to say has a bit of padding around it, doesn't go edge to edge, has a fixed size, and prefers the color scheme of dark. So we're telling this grid, take up all your natural size, don't attempt to be resizable on the screen, and then ensure we're always in dark mode, so we haven't got to worry about our text looking different colors in light or dark mode. It'll always be the way we design it here, always in dark mode. That's our first draft of our grid. Really simple to start off with. Press Command R to build and run your code. You should see a very simple grid of information appear, all being well. Let's find out. There we go. There's our little grid here of stuff. We'll obviously add that as we progress, as the game builds and builds and builds and more information. But because we have BioBlitz already here at the top, I don't want to also have it inside this title bar. Otherwise, like BioBlitz, that's rather pointless. So we can hide that title bar in macOS by going ahead and saying in our BioBlitz app Swift file, adding a modifier to our window group saying the window style should be .hidden title bar. Here is the first of the Ventura changes. If you're only going to target macOS Ventura or later, whatever Apple announce next, I suggest you add one more modifier here, which is called window resizability of content size. Otherwise, it'll allow the window to get bigger and smaller freely. It's only available, as you can see, on macOS 13.0 or later. Now, I'm trying to target 12 here. I'll just leave that off. Anyway, that's our starting point here. Just go ahead and show the current score of 0 and a rough grid of information showing all the bacteria the player have to control over time. Now, obviously, we need something more than a whole bunch of X's on the screen. That's not much fun here, right? And so, to bring this game to life, we want to add some code in here that decides what one grid cell needs to know in order to work, what properties it has to have, and also what one grid cell should look like. So Morland says, will most of the same code work if you're doing it on iOS? Almost all of it will work on iOS. You obviously haven't got Windows style available to you. The issue becomes a matter of space. Because you might find an iPhone screen's too small for your particular layout. It might work just about, depending on your grid size, or maybe add a scroll view around it, for example. But otherwise, space is rather constricted. As an iPad OS game, great. It'd look and work great on that. Enough space, easy to tap and so forth. But on iPhone, maybe it's a little bit too small. Anyway, we're going to decide what one of our grid cells needs to know, its properties, and also what it should look like. So that's a bit of data model and a bit of SwiftUI view code here. Now, in this game, this grid here each one of those X's will be some bacteria the player will try and take over as they play through the game. And so the colors will flip constantly as the game plays. Palette Fork, yes, it's a macOS application we're working with here because this is year 3, bit of variation now. Each bacteria in this grid will change constantly. Whenever they make a move, it might change 10 or 20 or 50 at a time as they play the game. And so the colors are constantly changing. And so to make it easier, we're going to store each bacteria, each cell in that grid as a class instance. So we can literally change it directly in the game rather than remaking it every single time it changes. And so what you want to do is make another new file inside your Xcode project, press Command N, choose Swift file, and name this thing bacteria.swift. Where are the dogs, someone asked? They're downstairs snoozing or barking or sniffing, whatever they normally do. They're around. You won't see this because the camera's not big enough by any means, but they're freshly groomed. They're groomed like 3 days ago, and so they look particularly fabulous right now, I think, at their Christmas brush up. Anyway, inside bacteria.swift, change the import foundation to import SwiftUI. We want to use the color struct here. And so we'll say inside here, there's a class called bacteria. And this has to know a handful of pieces of information. First, what row does it belong to? That'll be an int. And what column does it belong to? That'll be another int. And critically, what color is it right now? Who owns it? And by default, that will be color.gray. No one owns it. Well, now an initializer. We can say init with that lot. Boom. I'll remove color because gray's a perfectly fine default. Like that. And otherwise, it's good to go. Alex, yes, this will be available later on after the stream finishes. So, where is row and column and who owns it currently? That's what it knows as a bacteria, one cell inside our grid. But alongside that information, each bacteria needs to know what direction it points in, because that determines what it infects. If it points upwards, it infects the thing above it, points to the right, infects to the right, and so forth. So it has to know which direction it currently points towards. Now, at its simplest, this is just an enum. We can say as an enum called direction, and I'm putting this inside the bacteria class because it's only used by a bacteria class. It only belongs to that one thing. There's no board direction, for example. So a nested enum just clarifies what its purpose is. And I'll say this thing has case north, south, east, and west. Now later on, when it comes to building our game board up, we want to be able to pick out a random direction from that list. And the easiest way of doing that is making this whole enum conform to the case iterable protocol. Let us read an all cases property, an array of all the cases, north, south, east, and west. We just random one of those. So that's the simplest thing we can do. Which direction are you currently pointing in? But I want to add a few extra pieces of information inside here that will make the whole rest of our code much easier to work with. First, we're going to add a property here that will convert our directions, north, south, east, and west, into degrees. So we know how to draw this bacteria on the screen. Michael says, isn't it really a struct? No, it's a class, and I explained why. Rewind back 3 minutes, Michael. Here. So we're going to say a rotation from a direction. So we'll say var rotation is a double. And we'll switch on self inside there. And if we're north, we'll return 0. If we're south, we'll return 180. If we're east, we'll return 90. And if we're west, we will return 270. So it converts our directions into degrees on a circle. So we can rotate our view based on its actual direction, enum. Second, we're going to add another property that returns the opposite for this direction. So we ask for north, we'll get back south. We ask for west, we get back east. And this matters because we want to make sure when we generate our board, we flip the top and bottom sides. So we flip it around. Imagine like the player on one side and the player on the other side will have the exact same board as a mirror. So flip it in both directions. This matters because if we don't do that, we can have a board that's unfair. One player has lots and lots of moves that are really, really good and easy to make. Other player is stuck in a corner with nothing to do, for example. So we'll make sure we can rotate and flip the board nicely so both players have a same board to work with. So inside the enum again, we'll say there's an opposite property, which turns a different direction. Again, switch on self. And if we are the north case, return south. If we're the south case, return north. If we are the east case, return west, dot west, and if we're case west, return east, like that. Just making it easier to use this code elsewhere. Oscar, you think this is me typing fast? This is my slow keyboard. I have two keyboards. They're identical apart from the switches inside. One's red with cherry red switches, which is quiet. You probably hear me tapping away quietly. The other one's blue, which is cherry blue switches, which are much, much, much faster to type on, but they do sound like a machine gun, and so I don't use them on streams because, obvious reasons, it wouldn't sound good at all. After I take a pause to drink my medicine while you're following along. If you have this in your country, it's Lemsip. I love Lemsip. I had the flu the last few days, so this is a good thing for me right now. Anyway, we're going to add one last property here, which will tell us what's the next direction for this direction. Remember, when a player makes a move, they're going to rotate one of their bacteria 90 degrees, going clockwise. And so, when we say it's currently north, what's the next direction? It's east. That's east, the next is south. If it's south, the next is west. If it's west, the next is north. So again, it's just putting code in one simple place to move between the various possibilities of directions all in one place. So we'll say var next is a direction with switch on self again, case north, return east, so that's 90 degrees to the right, case east, return south, case south, south, return west, and case west, return north. It's going around the clock every time it rotates, like that. And so we're just putting all this rotation information in one fixed place. It makes it easy to understand, easy to group together. I am going to worry about all that code elsewhere in our project. It makes the rest of our code a lot easier. Now, each bacteria in our game has to have one of those directions at all times. So we'll say down here we have a row and a column and a color for the bacteria. We'll add another property here to the bacteria class here called direction, which will be direction.north by default. Santiago asks, why use case iterable? You're going to see really shortly, we want to make a random layout of our board. That means getting a random element from that enum. That's best done using case iterable, as you'll see. Anyway, that completes all the underlying data we need to store one bacteria in our game. And so I want to move on to making a SwiftUI view to draw one of these things on the screen. To do that, press Command N, make a new SwiftUI view. I'll give Oscar a moment to catch up. A new SwiftUI view. And you want to call this thing bacteria view.swift. And this has the job of rendering one bacteria on the screen somehow. So we'll say that this thing needs to know what bacteria to show. So we'll say var bacteria is one of our bacteria class instances. But also, we'll give this thing a closure to run when the bacteria has been pressed. What to do? So we'll say var rotation action is a method or a function that takes no params and returns void. Now, we're going to build this entire game. Hi, Marcus. This entire game for macOS, Marcus, without any assets. We're going to use SF symbols and colors for everything, which is why it's easy to follow along with. So, to do that, to get our image right, we'll make another property inside here called image, which returns a string. And this will return one of 3 different SF symbols graphics to work with. We'll first switch on bacteria.color. And if we are red, we'll send back chevron.up.square.fill. So it's a chevron pointing up the way with a filled square around it. If we are green, we'll return chevron.up.circle.fill. And if we're default, i.e. gray, but of course anything else potentially, we'll return chevron.up.circle. And I'm going to put that to use straight away inside our body down here with a Z stack. This Z stack will do 2 things. First, it'll show a button. It will call rotation action when it's pressed. And to label this button, we're going to show that image from the SF symbols library. That's the label of our button. Now I'll make this image, even though it's SF symbols, be resizable, which you normally would not want to do. I'll explain why shortly, but make it resizable. And also color this thing, foreground color here of our bacteria color. Now, on macOS, if you haven't done a macOS app before, if you use a button in macOS, you will get the default 3D push button design. So we're going to say button style plain to avoid that as a modifier for our button. And we have a fixed frame, width 32, height 32. Now, inside a Z stack here, because I want to add one more thing below it, which is a rectangle filled again with our bacteria color, with a frame fixed width of 3, height of 8, and offset Y of -20. And critically, a rotation effect with degrees of our bacteria, direction, rotation. Now that's quite a lot of code in that. I know it's only like, 15 lines or so, but there's quite a lot happening there. So before we use it in our content view, I want to walk you through what I've done and why. First, this thing takes that closure, the rotation action. When you use one of these views, you've got to tell me what to do when this button is tapped. And that'll end up being a call on our board saying, oh yeah, rotate that bacteria 90 degrees, right? But for now, it is saying, it'll be provided, please call it when I'm pressed. Second, I've used 3 different images for the bacteria in our grid. Now, obviously, we are using colors as well. There's a foreground color here and a fill color here for these things. And that matters so the players can see all the red stuff and the green stuff. That's great. But many, many players will be colorblind, and red-green colorblind is particularly common. And so we didn't use different shapes. They just see a wall of the same thing, all different kinds of grays or similar. So, by using a square for red, a circle for green, and an unfilled one for the default, they will stand out visually even without color. It's a small change, but it makes a huge difference to folks who have color blindness. Third, like I said, I've made the SF symbol use a resizable modifier, which you normally don't want to do. These things work much better when you say, I want a font of large title, whatever you want to. They size up and down very, very nicely like that. I have not done it here. These SF symbols, even though it's called square.fill, it's not actually completely square. It's a squashed rectangle. And so as they rotate around, they occupy different amounts of space on the screen, which looks pretty ugly. And so what I'm saying is, actually just scale up to fill your available space. They'll be stretched just slightly, but with that frame around them, they will always be exactly square. And so again, you wouldn't normally make these things resizable because it warps them, but it's warped by a tiny, tiny amount. It's not really perceptible, thanks to the frame keeping it in the right size. Remember, this button style matters. If you don't do it, you will see the macOS 3D button. It'll clip the image very badly around it. You do have to have that. That's a macOS thing you wouldn't normally have on iOS. This rectangle down here is interesting. So this is the button showing the bacteria image to work with. This thing is going to be placed at the top of the chevron. So SF symbols here is placed above it as a little stalk coming above it. And that exists so that the player can see connection line between all the bacteria that point to each other. So they can see at a glance the networks they can infect as they play the game. It helps make the game easier to work with. And critically, this rotation effect modifier is what turns the whole thing around, all 4 angles, as the player activates the game and works their way through. That rotates the bacteria around correctly. Now, Palette Fork saying, we've got to worry about previews. I quite like previews. I haven't got them on here because not enough screen space on my studio display, sadly. I do like them, and so really you want to keep them around. Just go ahead and modify your code down here to inject an example bacteria, just like bacteria can be a new bacteria with row 0, column 0, action of just nothing at all is fine. Like that. XYZ, it is my birthday. In fact, it's my birthday now. I'm doing this stream to raise money for folks experiencing homelessness. If you look on over there for you, I think this way somewhere maybe, this way, you will see a link to bit.ly/SwiftUI22 where you can donate to the reason I'm doing this fundraiser for, an important charity helping folks who've had domestic abuse or homelessness this winter. Anyway, that's our view done. And our model done now. I want to put it into action straight away so you can start to see the game building up nicely. So over in our content view, I'm going to say, ditch this whole text X thing and just temporarily make a new bacteria right here inside that code. Bacteria, row 0, column 0, and then use that immediately with the bacteria view. With bacteria of the bacteria, action of just rotate this bacteria like that. This is just temporary code so you can see up and running more quickly. Now, hopefully when I press Command R, boom, there we go. Our grid is slowly coming together. And you can see how those little rectangles, these little gray lines here at the top, how they work. They connect the bacteria together based on the direction they point in. And that will change over time as the bacteria move around the board, or rotate around the board, sorry. Anyway. Hopefully now you can get an idea of how the game's going to look. Some weird infinite stack. Oh dear. That normally happens, Michael, because, at least for me, when I forget one of these dots somewhere, if I write like that, for example, that causes absolute havoc with SwiftUI. Don't do that. You want to say dot there or here and similar. Otherwise, it'll have problems. Anyway, so that's the first major step of the game done. We've now got a meaningful grid on here. Obviously, it's not really random yet. They're all pointing in the same direction. There's no player colors in there yet. That's our next step. As a reminder, bit.ly/SwiftUI22. I am raising money for an important cause for folks experiencing homelessness this winter. It is extraordinarily bitterly cold out there right now, folks. Any donations you can support, we really, really appreciate it. Palette Fork wants to hold on content view. Sure, there you go. So, while Palette Fork screenshots that, I'm going to go ahead and discuss the next step. We want to actually introduce a real game board here. Because right now, here on line 30, we're making a new bacteria just temporarily so you can draw one of those bacteria views to the screen. Obviously, in real life, we want the real game board behind that tracks changes over time and players can conquer parts of the board and similar as they play the game. To do that, we're going to make a wholly separate class that tracks our game board. And this is going to be an observable object, so our SwiftUI view here can monitor that for changes and redraw itself as the game board changes over time. So, hopefully Palette Fork has got his screenshot, or got their screenshot, sorry. If not, let me know. I'll press Command N to make a new Swift file and call this gameboard.swift. Again, you want to change the foundation import to be SwiftUI. So you want to have the access to that color struct here. And this is going to be an observable object class that tracks our whole game board. So we'll say there's a class called gameboard, which is an observable object. I'm going to put in here two important constants that we had previously hard-coded in Content View. One is row count, which is 11, and the other is column count, which is 22. Those are fairly arbitrary sizes. By all means, experiment. Do check that, by the way, that your finished layout does still fit onto a macOS screen, like, one of the MacBook Airs with a large display scale enabled, whatever. Make sure it still fits. Otherwise, go to town with the number of rows and columns you want. Inside here, the most important thing is a published property called grid. And this is going to store the actual data for our rows and columns. And because we have rows and columns to work with, what we have is a two-dimensional array, or an array of arrays. So grid is going to be an array of arrays of bacteria. So we have an array for all our rows, and inside each row is an array of all the columns inside there. The good girls, Coffeeology, are downstairs, currently snoozing, I expect. They'll be around at some point. They never can resist a good live stream. So, an array of arrays for our bacteria here is a grid. It is a grid palette. Exactly that. It's a grid. Will it be on GitHub or not? Maybe. I'm not sure. I might zip and put it on the site something and then tweet it out. I'm not sure. Path mesh. I'm not sure. We'll see. Carsten, magic numbers are an antipath, and you're absolutely right. Although, to be fair, in a live stream, I don't really mind so much. When time is limited, you do what you can to get the result done. Okay. When we init this thing, we're immediately going to call a separate method called reset, like this. I'm doing it this way because I want to make sure, Michael, make sure you say observable object, not observed object. Up here, this thing, if you do that, you'll have problems. Don't do that. Hey, GGT, how you doing? We're doing it this way with init and reset so that we can make a new game later on. When the player wins, we call reset to get back to the original game again. We're going to remake the game board, but just reset what we have already. So inside reset, we're going to do a few things. First, importantly, call grid.removeAll. Zap all the rows we made earlier. There are currently none, but of course we call reset more than once. It'll have to reset fully each time. And then we're going to go ahead and make all the bacteria for our game board. And that means counting for row in 0 up to row count. So counting all through our row numbers like this down the line. And for each one of these rows, make an array. Remember, it's an array of arrays. So this row here will be, new row is an array of bacteria, like that. So we're in row 0. We've got an array here to store all the columns in row 0. So we'll now count inside there in a nested loop for col in 0 to column count. And for each column here, we can now make our bacteria. A new bacteria with row of row, col of col. And we'll append that to new row. Like that. So we'll make a new row, it's empty of arrays, a new array, it's empty. Add a bacteria, all the way down the line. Next row, bacteria, next row, again and again. Fill them all up. And we've added all the items here. We can go ahead and say, add that new row to our total grid. So I'll say grid.append the new row. Thomas, does it make a difference in terms of speed or scope with the import SwiftUI? Broadly speaking, you want to import what you need. If I were to flesh this game out bigger, I would probably try and remove the SwiftUI import completely and remove color and factor color out into a player enum or similar to avoid having to have SwiftUI here or in the bacteria thing here. it's too much really given the space. It doesn't cause any slowdown realistically. It's not a problem in terms of like performance of your application. It's more about when I import SwiftUI, I feel like I've polluted my code a little bit. I want my code to be fairly pure data where possible so I can write good unit tests for it. Hossein, it'll be online on YouTube for a long time, many, many years to watch back or rewind whenever you want to. It'll be online, relax. So this basically goes ahead, makes a new row, fills it full of bacteria, all pointing up the way, and then, thank you so much, Coffeeology, appreciated. And it puts that row onto the grid. And when that loop finishes, we're going to add two small changes. When the game is reset, the top left square will belong to the green player, and the bottom right square will belong to the red player. So each player has one starting position on the map. So we'll say that grid 0, 0 dot color is green. And then grid row count -1, column count -1 dot color is red. Laxia, Kumar, I guess. I'm sorry, I'm not sure his first name. I'm building a game for macOS. Bit of a change from the last 2 years, but a bit of variety. Keeps us on our toes, right? So give green one square and give GGT. I don't need to talk about. That's a whole other world of pain I don't know about. Anyway, one player has one color each, and that's enough to get our game board up and running on the screen. So to do that, you want to leave game board alone. Who was it? Oscar. Take a screenshot quick. And then go to content view, and we're going to make one of these things as an object for our content view by saying @state object private var board is a new game board. And now, rather than making a new bacteria every time we go through our loop, we'll just read out the correct version from our board. We'll say let bacteria equals board.grid @row and column, like that. And the result should look almost identical with two tiny changes. Boom. One green bacteria for the first player and one red bacteria down here for the other player. Hopefully, that's what you're all seeing. Kyle asks, are we going to see an update for ProSwift? ProSwift remains my all-time favorite book I've written. I would love to do an update. It's just a lot of work. I want to redo all the videos as well because they were done. As you say, 5 years ago, I was less keen on having large downloads, and now folks have got obviously a lot more storage space. I kind of want to see 1080p across the board for those as well. So I do want to do it. I'd love to do it. It takes more thinking than a quick sort of like refresh. I want to really, really do a big job on it, if that makes sense. Anyway, there's our board so far. You can see it coming together a little bit now. It's green and red down there. Of course, we can't just always have up the way, right? The board is quite dull to begin with, it's up the way. Instead, we want to randomize the board so that every game is slightly different. But we don't want a truly random board for two reasons. One I mentioned earlier, which is that if it's truly random, actually this player, the green player, might have significantly easier moves than the red player. And so, rather than doing that, we'll instead randomize only half the board and then mirror the other half so both players make exactly the same moves if they want to, because the board is a direct copy, flipped around like from green to red, like that. Otherwise, it's not really fair. Second, we want each player to start off with exactly one bacteria, which means making sure nothing else is pointing to it or gets pointed to by them. So for example, if we start with this thing here, you can see red is pointing upwards to here. This should be red. It should in fact all be red all the way up here because red should infect all those with its direction. We don't want that. So we're going to make both red and green always face away and make sure nothing points to it so they can't trigger an infection at the very beginning of the game. So to do that, inside our game board class, we have all this code here to make a new bacteria and append it here. Right in the middle of those two, make the bacteria and appended the bacteria in between those lines of code here on line 29 for me. We're going to put some logic in here to randomize half the board correctly. So we'll say if our row number is less than or equal to our row count divided by 2. Then we'll do stuff. Now, like I said, if the row is 0 and the col is 0, this is the green player's starting position. So we want to make sure the player starts pointing away from anything. Like this. Now, the direction is north by default, but there's no harm being sure here. So we'll say our bacteria has a direction of north, like that. So that's if it's a top left corner. But else if row is 0 and col is 1. This is 1 to the side of green starting square. We want to make sure nothing points to the player. So we'll say here, make sure nothing points to the player. We'll do bacteria, direction is always east. Always point away from the player's starting position. Similarly, if row is 1 and col is 0, this is directly below the player's starting position. Again, we want to make sure nothing points to the player. We'll do bacteria.direction is south. Always point away from the player at the beginning. And for everything else, that top half of the board, so all other pieces, these are going to be random. So we can say bacteria.direction is, now someone asked earlier, why did I add case iterable support to the direction enum? This is why. Bacteria.direction.allcases.random element. So it'll pick north, south, east or west randomly for the whole rest of the top half of the board. That's what it's doing. Now I've said a few times there, the top half of the board only. That is right here. If the row is less than row count divided by 2. If we are all the other rows down here, that's the bottom half of our thing, then we want to try and remove randomness here. We want to copy and mirror what's in the above thing. So we'll say mirror the counterpart here. Now, if I press Command R, you should at least now see half the board being randomized. You can sort of see it pointing right, down, whatever, left, all over the place. But on the bottom side here, this whole thing, they're all pointing up the way. That's the mirroring code we still have to write here. So we're going to mirror these things horizontally and vertically. So it's like the inverse moves for both players, so they get identical positions. There's no unfair advantage for either player here. And we're going to do this carefully because, yes, we can just read into the array, read X and Y, blah, 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 blah. But later on, we're going to do exactly the same thing to handle infection code. And so I want to make sure we don't accidentally read outside our array. So we'll do this very carefully. We'll add a new method. Folks, Prathamesh is very carefully policing the YouTube chat. Thank you, Prathamesh. If anyone steps out of line, he knows you are gone. I have zero patience for harassment or abuse. Anyway, we'll write a method here that gets a bacteria at some row int and col int, and it return optional bacteria. Like I said, it'll be very, very careful in understanding what it sends back. We're not going to index into the thing directly. We'll check, is it inside our grid? So it's safe to call us with numbers that are outside the grid. It'll send back nil happily. So we'll say, check first that row is greater or equal to 0. Otherwise, send back nil. Oops, space there. Then guard that row is less than grid.count. So is it inside our row numbers? Again, if it isn't, return nil. Then guard that our column is greater than 0. If it isn't, send back nil. I see spent space there again. And then guard that col is less than one of our column lengths. It's all the same length. We'll do grid 0 count, otherwise return nil. So if it lies outside the bounds of our rows or columns, just send back nil. Otherwise, send back grid row col. So it's safe to call this with any number row, any number column, including negative numbers. It will still return nil safely. Better than reading to the array directly. And now we can write this mirror the counterpart code by calling that method here. We can say if let counterpart equals get bacteria at row, and we're going to read our row count. So it was 11, I think it was, minus 1, so because it's 0 to 10, minus our row. So the opposite row from where we are. So row 0 reads 10. Row 1 reads, row 10 reads 0. Row 9 reads 1. Row 8 reads 2, and so forth. Inwards like that. And for our column, will be the same thing again. Column count minus 1 minus col, like that. So it looks for the opposite row and the opposite column, and will copy its position into here, like that. That's what it's going to do. So if we found a bacteria there, great. We'll say that our bacteria's direction is our counterpart's direction opposite. Flip it around like that. So, hopefully with that, we now have a complete board. Let's find out. There we go. So you can see that they are direct opposites now. So it's pointing upwards or downwards here. There's a left and a right next to it, or a left and an up across here, and similar. So the boards are flipped completely, horizontally and vertically. So there's a right down here, there's a left up here, and so forth, all neatly flipped. So that's our board coming together very nicely now, I think. You can see we have one color each. The board's now randomized across everywhere. It's ready to go. Akash keeps asking the same question. Please don't. You will be removed from the channel entirely. I haven't the patience for folks spamming like that. One let per line. Yeah, you can do that. I'm not a big fan of doing that. I think someone said I find it easier as well doing this. I just do whatever works for you. I find it easier to have one per line. I'm a simple man. Whatever works for me, you know, it's very, very simple. Anyway, so, oh, hello. Is it dog treat time? Folks, the dogs have arrived. They're keen to have some treats by the looks of it. Yes, hungry dogs. The problem is, you know, I'm thinking I've got this big box of dog treats here. Maybe like one donation for one dog treat. They look so hungry. These dogs look hungry. It's bit.ly/SwiftUI22. If you want to donate there, folks, if you want to get yourself some dog treats, donate something there. Anything really. It goes to an amazing cause, helping folks experiencing homelessness this winter. If you can, please donate there, and my dogs will get a treat. They'll get a treat thanks to you and your donations. If you donate, please mention in the chat as well, and I'll make sure they get a treat. Otherwise, I might miss it by accident. Otherwise, the dogs miss out, do we? No. And they're very hungry. Look at this cute face. So hungry. So hungry. So desperate to work hard for charity, aren't you? And hungry as well. Anyway, donate, and my dog get a treat. Otherwise, they get nothing. You cruel people. Okay, so we now have our game board working correctly, and the next step really is to let people take over the board by playing the game and doing things. Oh, Tim, disaster! Oh, I know you're hungry. I know you're hungry, dogs. I'm sorry. You've got to donate to get some treats. My dog breed is a Samoyed Artemi. They are like huskies, spit style dog. They love walking and similar. Oh, there we go. You've got a donation, dogs. You are lucky. Is that Adam? Oh, Aiden, sorry. One for you, and one for you. There you go. Good dogs. Another donation. Gosh, dogs. 2 back to back. Yes. You hungry, aren't you? Yeah. Go on, you. You got one too. And a third donation. Goodness me. Dog treat giver. Thank you very much, folks. I know I'm making fun of it because it is quite fun, but this money goes to a really, really important cause. You know, folks experiencing homelessness or domestic abuse this winter. It's a really hard time to be in those situations, more so than ever. And so I really appreciate your support. And the dogs do too. And well, don't worry, we watch our dogs very carefully in how much they eat, and they are very skinny. You can actually feel their ribs if you dig in through the fur. Good dogs. Anyway, back to the project. We've got a real board now. You can see it looking nice. So the main part of the game's coming up, letting players actually, another nation, letting players actually take over the board by capturing pieces. Go on, Lou. Good dog. Capturing pieces. Now, we're going to implement this in 3 passes to get exactly the kind of result I want. We'll start simple. Another donation. Thank you, Anonymous. I'm just going to pop it to one side for a minute, okay? So the dogs don't get sick too quickly, you monsters. They get one soon, don't worry. So we're going to implement in 3 passes. Nice and simple, then a bit more complicated, then a bit more complicated again. And you'll see why. You see it improve over time. Now, the first pass is simple enough. Down you go. Wait a minute, please. You have to wait just a minute. You wait. When the player rotates some bacteria on the board, we want to make sure that we infect whatever the bacteria now points to. That's how the game works. But the infection shouldn't stop there. If they infect this one might infect this one, and this one, and this one, it might spread across 10 or 20 or 100 pieces, depending on the game's layout as it is right now. And so, this means creating a recursive function, a function that calls itself again and again and again until all appropriate bacteria have been infected. That's the goal. And so, we're going to write this thing bit by bit, like I said, in 3 passes, starting out small, and a better version, and then a better version again. So, first things first, our first pass, we'll add a new method inside game board called infect from a bacteria. This. And we stack some more code to come in here. Well, the middle one is handled through the comparison. Come on, you. Good dog. Because we have 11 rows, we divide by 2, and so we get 5 or 6, whatever it happens to be. Anyway. Well, we'll come back to that, Gree. That's a great question. Does the bacteria infect if they face the same arrow direction? We'll come back to that. I said multiple passes here, step by step by step. Anyway, inside here, you horror. You want more treats. They've got to donate more, dogs. I'm sorry. They've got to donate more. It's for a good cause, dogs. You being hungry is a good cause, trust me. So, inside here, someone donated straight away. Look, inside here, we're going to start with the easy thing, good dogs, which is telling SwiftUI our board is about to change so it can handle all the updates correctly with our SwiftUI view. So we'll start by calling object will change.send. I'm about to change, watch out. Now, inside here, we're going to make an array of all the bacteria instances that we have to check for infection. This will only actually contain a single object, thank you Anonymous, for now. A single bacteria will be in there for now, but that will change really soon. So we'll make an array to store these things. var bacteria to infect equals an array of bacteria. Now, if you remember, when we call get bacteria for a particular row and column, this thing sends back an optional bacteria. There might be nothing at that row and column you requested for safety reasons. And so I will make this array also optional. It might have some nils in there. It might all be bacteria. We don't know. We'll check it very carefully. And now we can figure out what bacteria to infect by looking at our direction of the bacteria and calling get bacteria on it with the row and column we're pointing to. So we'll say, if we're pointing up, read the one above. Pointing down, read the one below. Pointing left, point to the one left. Again and again for all 4 directions here. So we can say switch our from direction here. And if we're now pointing north, then we want to add to this array bacteria to infect append the result of calling get bacteria at row from.row -1 and call from.call. So we're pointing up the way. So we read the bacteria that's one row above us in the same column. We're pointing north. And I'll just copy and paste that a few times. So we'll have this. We're pointing south. We want row +1, the row below us. When we're pointing east, we want the same row as us, but the column should be +1. So 1 to the right, which is that way for you on the screen. I can't tell. Anyway, reverse to me. That way, I think, for you. And then when we're pointing west, we'll say -1. So read 1 to the left. And now you can see why we have this method in the first place. If we rotate the very top left one, we don't want to accidentally read row -1. That'd be broken. And so we have these checks here to make sure we never read outside our grid spaces here. So this code will run and find the bacteria we should now infect based on what we're pointing to. Like that. Now, we now know what to infect next. Question is, what do we do now? Thank you, Carl. Doggos? You got a friend? Oh, one dog downstairs. That means they're both for you. Where's Aria? Aria? She's gone. All right, I hear some paws scrabbling downstairs. Now we know what to do with this. We're going to loop over the array and read out all the non-optional values. Go, Larry, come on. You haven't already, you horror. All the non-optional values. We're going to do that by saying for case let. If we say for case let bacteria, question mark. Oh yeah, sorry. This one here. Thank you. Good spot. I'll be very confused later on. For case let bacteria question mark in bacteria to infect. So Howard asks, where does a from variable come from? This thing will be called with whatever bacteria we just rotated. So we're saying infect from this thing. And it'll find all the things it now points to and then loop over them all here. Now what we're saying here is find me all the non-optional values and unwrap them safely for us to use. Don't give us any nils inside this. What are you doing? Get out. Sniffing around down there for some reason. Anyway, read the non-optional values. And we'll say if this bacteria's color is not the same as our from color, then it should be infected. So we'll say that this bacteria's color is from.color. And remember, when we infect another square in the grid, we might want to spread the infection on further. So we now call infect from that bacteria. Pass on to there and check from there and from there and from anywhere else, potentially infecting 100 or 200 pieces at a time. A lot. And that completes the first draft of our infect from method. But before we make it better with the second and third pass, I want to actually make it work in the game so you can see it in action. This means adding a second method to this game board class here that will handle rotating a single bacteria on the game and handling an infection from there. So I'll say func rotate bacteria, some bacteria. Call object will change.send. Change our bacteria's direction. So it was direction and now will be bacteria.direction.next. Again, cycles its way around the clock. And then calls infect from that bacteria. So that triggers the initial infection. And once we call infect once, it can call itself again and again and again to spread the infection across the board. So now we can go back to content view up here. And we have this little comment saying rotate the bacteria. I'll make this thing become board.rotate bacteria, that bacteria. And now, give it a try. Press Command R to run the code. You should find it works quite well. I've got my -1s incorrect, perhaps. Who knows? I'll press one here. There you go. I've got those 3 now. I can go down here, or down here, across here, and similar. So you can see I'm now occupying large parts of the board as I rotate further and further, like this. Anmol, calling object will change, tells SwiftUI that we're about to update our program state. We're about to change something important. And so it notifies it needs to be prepared to re-invoke the body property for any SwiftUI views that are watching this particular object on the next run loop. There, bacteria are spreading in. Retracted, there you are, Sagal. I'm not sure what you mean. Anyway, so you can see it's kind of working, right? Works well. It's a good start. But I want this method to do more. Because right now, we have implemented what I call direct infection. If this one here, for example, points upwards, it infects the one up there it's pointing to. That makes sense. A bacteria infects what it points to. Hey Yash, how are you doing? I want to also add a thing I call indirect infection, which means if something points towards an infected bacteria, it spreads that way. For example, down here you can see I have this little box of green ones. The middle one points to the right at this infected one. So even though this one here doesn't point left, the one here points to the right, it should be infected indirectly. And so this is why we have our little array of things to infect inside Gameboard, because I want to add more than one thing inside there to handle both direct and indirect infections. This means adding another set of checks. So this whole thing here is direct infection. Direct infection. Once that's done, I want to handle indirect infection. It takes a bit more thinking, but not much, fortunately. So we'll say here, after doing direct, we'll say we have an indirect infection from above. Here. Naman, yes, it will. It's about to change. It's about to change. Here. Boom. At above. Then we'll do below. Then we'll do left. Then we'll do right. We have indirect infection from all 4 sides here. So it's the same code again and again with different -1s or +1s, but you get the idea. We'll say if let indirect equals get bacteria at row from dot row -1 col from dot col. So the one above us here. And if indirect direction direction equals south, then bacteria to infect append indirect. So we're saying find me the bacteria above me. If that points downwards towards the thing that was just infected, spread the infection indirectly like that. So that's how we do it from above, like that. For below, it's basically the same code, except now we're going to say not -1, but +1, and not direction south, but direction north. Does the one below us point towards us, is what we're saying now. For left, we'll say our row is just a regular row, but the col should be -1, and the direction should be east. Does the one to our left point to the right? If it does, add it to our array. And then finally, indirect from the right will be col +1, like that, and direction west. Does the one to our right point to the left? So now we have direct and indirect infection, which spreads faster now. So if I press Command R, hopefully, we'll just see how it looks. If I infect this way, so you can see to my right, the green is one pointing right, one pointing up, and one pointing left. This will be indirectly infected Because this one points up the way, it should end the infection, but actually it'll catch it via this one here pointing to the right, like that. So now the infection spreads much, much faster because we have both direct and indirect infection happening, which is great. Boom. That's our second pass at this infect from method complete. And it's a lot better now. The game spreads much faster. In fact, it's so much faster, the third pass of this method will be trying to make it clearer what's going on. Because now things can change very quickly, like 20 or 30 or 100 become green or red in one click. It can be kind of hard to follow. And so this third pass, what we're going to do is we're going to slow things down, which means when we have this nested call to infect, this recursive call to infect, where infect from calls itself, rather than calling immediately, we're instead going to start a new task to do it after a small delay, a tiny delay. So you can see it spread out visually on the screen. Now, obviously, a very long delay, you'll see it spread out very slowly. A quick delay will spread out very fast. It's down to the experiment. Point is, it won't be all at once anymore. It'll be done in very small stages. So I'm going to keep the color change immediately, but then put around this call to infect a new task like this. Now inside there, we don't want to call infect from bacteria straight away. We want a small delay. This is the second Ventura change if you want to target only macOS Ventura and later. I'm trying to do macOS 12 and 13 here, so I've got to say try await task.sleep nanoseconds 50 million, like that. This waits for 1/20th of a second in order to get your delay about right. If you are doing Ventura or later, you would instead say try await task.sleep 4 and then do milliseconds 50. It's a much nicer API than the old nanosecond approach, but only available in macOS 13 and later. And so I recommend you very carefully choose which platform you want to support. So I'm going to use the older version, so it works here. Now, before we run this code, I'm going to add one small change here. When you make a task like this, it can run anywhere, on any task, background, foreground, who knows what. We want to make sure this code runs on our main actor, like this. So it will happily sleep for a while and then do the infection, but always on the main actor, because this will trigger UI updates. We don't want a UI update on a background thread. It's a bad idea. Always do it in the main actor here. So hopefully now, with that small delay in place, you'll see it spreads out more visually on the screen, like that. And of course, you can change it to be higher or lower. It's down to you how fast or slow you want it to be. But you can see if I take over these greens now, you see it spread a lot of places. It's more interesting now. Boom. Beautiful. It's a tiny change, but it makes a lovely little difference here in terms of seeing how the whole thing looks and works. Yash, I mean, the thing is, Yash, the whole thing actually is main actor already because of the state object property wrapper. I believe this is fixed now in Xcode. If I jump to state object over here, we should see it marked as main actor somewhere. It certainly used to. There we are, see? It does automatically, implicitly become main actor, but it will still happily go to the background thread thanks to that task. You'll be very, very careful. And so just being sure this task's body, this thing here, is definitely going to be main actor. That's what matters most. Ryan, why don't you use dispatch queue? Because I'm writing modern Swift, I think is the answer. There's no easier answer than that, really. Naman, again, you don't, Naaman, sorry, you haven't got to worry about marking individual functions. The whole thing is implicitly main actor. That's the way the property wrapper works. When you have at state object, the whole class becomes implicitly main actor, which is what it does. Anyway, so now we've got infections looking very, very nice on the screen. You can customize the delay, they go faster and slower. This game is coming together. You can see we can now, red can conquer green. It's all very nice now, coming together very nicely. Next up, we're going to track scores and, of course, end the game when we have our UI finished with 0. But beforehand, a reminder, today's my birthday. Thank you for all the very kind birthday wishes. I am running this stream on my birthday because I am raising money for an important charity that works with folks who are experiencing homelessness or have suffered domestic abuse. Right now, it's a particularly horrible time. It's winter. It's cold out there. If you can spare even a few bucks, please visit bit.ly/SwiftUI22 and donate what you can. It is really, really appreciated. Thank you so much. And my dogs will get treats too. Look at these. These are treats my dogs will be eating right now if you donate. So it's your chance to see my dogs come on again and get some more food. They're very, very hungry dogs. We never feed them clearly. They're very hungry for treats. And of course, it goes to a great cause too. Anyway, let's try and track our player progress. Let's add score tracking and, of course, the game ending as things happen. That's when the game becomes, real. And we want to make sure we can alternate between players. So you can't just go, green, 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 again and again and again. It's obviously not very fair. Alternate red, green, red, green, red, green, and also end the game appropriately. Now, doing all this means adding 4 new properties to our game board class up here. One will be which player is currently in control of the game. So I'll say for that we have at published var current player is color.green, like that. One will be the current score of the green player. This would be just the total sum of bacteria under their controls, all the green bacteria. So we'll say at published var green score is 1, which is by default. Another will be the red score. So that'll be the same thing again, but red score. Oops, with a lowercase c is 1, like that. And then one extra one here, which will be var bacteria being infected is 0. Now this last one is important because of that delay we just added. Now previously, if there was no delay, when you rotate one piece, it might infect 100 other pieces instantly. And so as soon as they press rotate, we can change players. But now I've got a delay. It's not a big delay, but it's still a delay. It might take 2 seconds, 3 seconds for the whole thing to finish infecting, right? And so we cannot say change player as soon as they press their thing, because the infection might not have finished yet. And so this thing will track how many bacteria are currently in the process of being infected. And it starts out as 0, we'll add to it as we infect things, and subtract as we finish infecting it. And when it ends up being 0, it means the infection wave is finished. Oh, a donation. Doggos! And then when I hit 0 again, we know it's safe to change player or potentially end the game. Okay? Makes sense? So it's 0 to begin with, adds up as we infect things, subtract as we finish infecting, and when it hits 0 again, oh, more treats. Thank you very much, people. Very kind of you. It's very, very kind of you. It really is. It's an important cause. It really is. So when it hits 0, change player or end the game. So, changing player, that's easy, right? We can go down here and add a new method that is toggles between green and red freely. So we'll say there's a function called change player. And if the current player is green, doggos, hi, come on, get a treat then. Come on, Luna and Aria. You're good dogs. Yes, you are. They're very nice to you. They like you a lot. They really do. They really do. In fact, I think there's more than one, so come on. I have to extra walks tomorrow, Walk off all these treats. So if it's green, simple. Current player is red. Else there's another player here. Current player is green. Another donation. Goodness me. Try wait, donate for the dog. I'm liking the comedy donation names. There you go. Luna, come on. Good dogs. I actually got different kinds of treats, shouldn't I? Really? There's so many treats you get in them right now. I should have different varieties over the stream. So this thing, all it does is toggle player. It was green, make it red. It was red, make it green. Again. Yeah. Dammy, sorry. Why have published and object will change? I don't think it really matters that much. At published literally just calls object will change send. And so having it more than required, I'm not too worried about. We could probably experiment there and not have those. I'd be keen to see, ship out what you can do. I certainly agree that not having it, if it's not required, is a good thing. But right now, it's just playing it safe. Anyway, that's changed player written. As for the scores, I want to change these whenever we've finished doing something, right? We control our bacteria's changed once or 100 times, whatever it is, change the score again and again and again, and publish those out to the world, so they'll be told, oh yeah, there's new scores, update the UI. This means literally looping over all the rows and all the columns inside those rows and adding one to either score depending on who controls that bacteria. So down here, we'll add a new method called, helpfully, update scores. Let's have a new red score of 0 and a new green score of 0. And all we're going to do is loop over all the squares and see who has what. So we'll do for row in grid, for bacteria in row. If the bacteria has a color of red, then new red score plus equals 1. Else if bacteria color is green, then new green score plus equals 1. Simple counting. Count them all, red and green, and when we're finished, copy that into red score and into green score. Boom. Now I'm going to add a little comment here saying more code to come, because it is a little bit more work I want to put inside here. This is a great place to take some action when a turn is finished. We now know the new scores. Now again, we're going to track when that turn is finished based on this little property I added earlier called bacteria being infected. So it might take a while for the whole wave of infections to finish. And so we'll say, start at 0, count our way up, and then down again, and we're finished. We're finished. Go to the next thing. Oh, another donation. You are lucky dogs. You really are. They've gone away again, I think. Back to sleep again. Don't worry. I put them on the side here. They'll get them later on. They're not going to miss out. bit.ly/SwiftUI. SwiftUI22, sorry. Vitali, sorry, my Cyrillic's terrible, is asking, why not add the green and red scores directly? This is an area where I would prefer not to. This thing will be calling object will change potentially 200 times if I modified that directly inside the loop. And I wouldn't want to do that. I don't mind calling it twice in a run loop, because I've called it myself and once throughout published, but I wouldn't call it 200 times. That seems wasteful. And so by putting in a little temporary value here and then copying it across when I'm ready, it would work out better, I would say. Anyway, we want to make sure we are. I didn't use private var. Did I use private var? For what? Up here? Yeah, that can be private. Yeah, that's fine. Thank you, Hans. We want to make sure we're modifying bacteria being infected so it gets higher when we've disinfected the bacteria and lower when we've finished spreading it from there. And so we want to find our infect from method down here. Here we go. And after we literally change the bacteria, yes, you are now infected, I'm going to add bacteria be infected plus equals 1. Add to that. We've just spread somewhere else. And then in our task here, before we call infect from there, I'm going to subtract 1 from there. We are now about to infect from that location outwards. So we're about to infect from there. Get ready for it. And it's now about to happen. Subtract it again. And it eventually means when this final infect from bacteria call is triggered, the final end of our infection happens. Ideally, bacteria being infected should now be 0. The turn has finished, the final thing's infected, the game's over, or we change players. So we can do that inside our update scores method down here. So at this point, we've now gone ahead and counted all our scores again. We can see, is the red player or green player completely out of bacteria after we just refresh the scores. If they are, boom, the game's over. Otherwise, call change player. So, inside this update scores method, I'm going to say if our bacteria being infected is 0, we'll have a little animation. I'm using spring animation because it looks quite nice when you end the game. If our red score is 0, then green wins. Red's out of bacteria, done. Hey, Ioannis, good to see you again. Otherwise, if green... Oops, I'm typing there completely off. Else, if green score is 0, then red wins. Otherwise, both people have bacteria in play right now. The game's not over yet. We'll just call change player. Like that. And that completes our little update scores method. So what we'll do is make sure we call that from somewhere. The question is, how often should we update our scores? And in my opinion, always. Whenever anything happens, any infection changes even one thing out of 200, update again and again and again. So the score will like roll upwards and cat up and down freely as the score constantly changing. Michael, thank you for your donation. It's always good to see you. Thank you so much. So the score will roll upwards and roll downwards as infections happen live on the screen. We can get this by adding another call to our infect from method here. So this is a whole infect from method here, this infection. At the very end, after the 4-case let loop, I'm going to call update scores. So always call update scores regularly. Yoaz, I still do use Twitter, although I cross-post everything to Mastodon. I am 2straws at mastodon.social. Anyway, that completes all the logic for updating our scores as play progresses. But it won't show anything on the screen. That's because we've hard-coded our UI to always show green 0, red 0. That was the first thing we wrote in our code there. So over here we have green 0, red 0, boom. Obviously that should show real values. It should show the green score and red score here. And that's enough to do. We'll just say green should be board.greenscore and red should be board.redscore. But while we're here, I want to add a little bit extra to these text views so the player can see who is currently in control. And to do that, we're going to add some modifiers to these views here. We'll say that the text has some padding horizontally, with a background behind it using a capsule shape filled in with green and opacity. And the opacity is there because when the green player is in control, we're going to use opacity 1. So it shows a nice green background behind the word green. Otherwise, make it invisible. So we'll say opacity, if our board current player is green, then use 1, otherwise 0. And I'm going to copy that across to the red down here. So now it will be obviously a fill of red. And then board current player is red, like that. And so just allow the green and red to highlight or not highlight based on who's in control. Yash is asking, why do you have a question mark in the 4-case let loop? It's over here. This thing. This array, bacteria to infect, is actually an array of optional bacteria. So it might be nil, 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 some bacteria, or all bacteria, or who knows what. I don't care about the nils. Just get rid of them. I don't want them. And so this means, the loop means, go over the array, find me all the non-optional values that have real values inside, things inside the optional, extract them, unwrap them, and give them to me inside the loop as unwrapped values to work with. And so here, it's no longer optional anymore. It's always a real bacteria. It just discards the nils immediately, like that. Okay, I'll press Command R. I can build and run and hopefully give it a try. And then there we go. So you can see now green 1 is highlighted because a nice green background there. And I change players, hopefully. Boom. Red pops up. And it's now red in control. Now green. And now red. And so forth. Like that. So it's changing players correctly and highlighting who's in control at all times. SJK asks, in a more complicated board, would I advise making infect and rotate a recursive func as asynchronous for any performance benefits? You know, a lot of time and effort has been spent making code asynchronous that really ought not to be asynchronous. You know, there's a lot of places where it can matter. This is not one of them. They're very, very simple calls. You'd in fact probably tie stuff in knots trying to make it asynchronous. David Smith, Catfish Man, he used to tweet about this a lot, and he said he'd tweet about, back when he did this full time, him saving stacks and stacks of time making things faster by making them not asynchronous in Foundation. And so, broadly speaking, start simple and change only when you actually have to. Oh, hello. Ah, thank you. All right, how are you doing?
Good.
Kiss. Wave, you're on. This is Lottie, by the way, folks. She's here. And
Hello.
these folks are very kindly donating to our charity, the Julian House.
Ooh.
And they've been given dog treats for everyone. They haven't been given. The dogs have been given dog treats to every donation that comes in. So the dogs have been very, very, very well fed treats. As a reminder, folks, bit.ly/SwiftUI22 donates to a local charity here in Bath that help folks experiencing homelessness and domestic abuse. It's really, really a great charity. Thank you for your support. Anyway.
Bye-bye.
They're waving back to you. All right, bye. Oh, I love that t-shirt. I love the t-shirt. Lottie? Yeah? You want to see a t-shirt? Yeah. It says, fight like a girl. And it's Wonder Woman. That's a great t-shirt, isn't it? High five. Yeah, fight like a girl. All right, thank you very much.
Bye-bye.
Okay. So, the game's almost done. I say almost. Because there is one significant problem. It's not great. And I think it's been spotted by Michael 47915. Which is that it's green's turn right now, and I can basically press on any bacteria I want, like some grey thing over here, or red can change green's moves and so forth. Everyone can change any bacteria, which is obviously not the point. We don't want that. We want to have an actual game where you control only your own pieces, and so we can fix this by adding guard checks inside this rotate method here. Do not let them rotate things when it's not their turn and there's currently an infection in place. Both those things matter. A whole bunch of questions. Germund asks, how are funds being used? Julian House is a local charity here in my town, Bath, that specifically house folks experiencing homelessness or domestic abuse. They do wonderful, wonderful work. They have a place where they can stay, short-term accommodation, and so it goes straight to them. I don't see any money here. That link, bit.ly/SwiftUI22, you're giving the money straight to them, not to me. That's how it's used, and they do great, great work. Codenexus asks, why am I not using turning operators? I do when it's required. Normally, it gets quite messy sometimes, but often I do. Not always, though. If there's like a three-way, before we had like the... this one, where was it back? Three-way somewhere, didn't we? Where was it? Oh, here, the images. Here. This, I won't use a turning for that. You can do. I wouldn't do. It's ugly as heck, but you can do. Boom. Natalie, yeah, it's a great t-shirt. It's a great t-shirt. I love that one. And the other one she likes is Princess Peach sort of doing the arm thing from World War II, saying, I can save myself. She loves her t-shirts. Anyway, let's focus on where we are. Right, guard statements and rotate. We're going to say inside here, make sure that this bacteria color we're trying to rotate belongs to the current player. Otherwise, do nothing. Return. Just bail out if they're trying to change a thing that's not belonging to them. And secondly, we'll guard that bacteria being infected is 0, else return. And this stops players trying to make 2 moves, or 3 or 4, because they can start one and it's infecting stuff, and it's still their turn, and while the infection's happening, try and change another one, again, and again. This means do not let them change anything if there's currently an active infection wave happening. And with those 2 changes in place, now the game is getting quite real. It's green turn, I can no longer now change any red or any grey and similar. It's no longer possible. I've got to change only green pieces and only once. I can't change multiple reds, for example. It doesn't work. Only one move each time. So it's getting better. Robert asks, wouldn't it be fast using compact map? Robert, you know Swift is just open source. I mean, you can just look it up, right? If I try and open a, GitHub, Apple, Swift, whatever. Just look it up. I mean, stdlib, public, core. Where would compact map be? Sequence algorithms, perhaps, or sequence? One of these two. Here, probably. Compact map. There you go. There you go. It's just doing a 4-element itself and doing unwrap here. It's just the same thing. It's just the same thing in a functional looking way because you've called compact map. There's no extra magic happening there. It's just the same thing. Anyway, slight diversion. I love reading the Swift source code. I recommend folks look at it all the time. Anyway, the game's almost done. The game becomes real, right? You can now only take turns, move things at your turn and similar. You can't cheat anymore or move the grey ones. It's almost done. Now, to actually end the game, we're going to check, are we out of greens or reds? And if so, declare a winner. But before I do that, a reminder, I'm raising money on my birthday. You know what for by now, hopefully. If you're joining late, though, it's for folks experiencing homelessness or domestic abuse this winter. You can go to bit.ly/SwiftUI22. Any donation is most appreciated. These folks really need our help. That's why I'm giving my birthday time for them. Anyway, let's finish our game. At this point, we need only like a couple of small changes to get the whole thing actually working. And that means actually ending the game. Now, we already have code in place that handles changing player and handles counting scores and prepares for green winning and red winning. What we've got to do is actually track inside there who wins. And so, way at the top, we're going to say, there's a new property here, @published, var winner is an optional string equal to nil by default. No one's won by default. Now we've got to put that thing to green or red when someone actually wins, but also when we hit reset, when it's time to start a new game, we've got to clear the winner. So no one wins in the next game. And so inside there, here, we're going to say that when we call reset, winner is back to being nil again. Let's do it there. And while we're here, I also want to make sure we have current player is green. So it starts being green again. And we'll also reset red score to be 1 and green score to be 1. Like that. So we reset our board completely ready for a new game. Now, we don't want the player making more moves after the game's finished. That'd be weird. They've won. Enjoy their victory, right? Don't let them carry on making moves. And so that means adding another guard down with our rotate method. All the way down here. Got these two guards already. Add another one down here. Guard, winner is nil. Else, return. Stop making moves after we've got an actual winner declared. And most importantly, we're going to set a winner value in those two comments down at update scores. So if green wins or red wins, put these things into there. So I'll say winner is green or winner is red. Yash, I'm going to put it on GitHub. Yeah, or something like that. I'll put it somewhere for sure. So we now mark it who won, green or red. And when the game finally ends, we're going to tell players who won and also give them the chance to start a new game, to reset the whole game board and try again. Now we're going to do this as a simple overlay on top of our game board, which is why, right at the beginning, I added a extra VStack. There's outer VStack here and an inner VStack here just for handling the game board. That's the game board here. And so this outer VStack handles the scores plus the inner VStack. But I'm going to wrap that inner VStack inside a Z stack or a Z stack like this. So a Z stack around that nested VStack, because this is where we'll do our overlay. We'll show two things here. Show the game board, and over it show game over. Red wins, play again, or something like that, when we have an actual winner declared. And so we have to have a Z stack for that whole area to handle that overlay here. Johannes, am I intentionally not using enums? I have an enum. I've got a great enum. It works good. It's called direction. Brilliant enum. Anyway, having this thing here. Johannes, I did mention that earlier briefly, but you obviously missed it. Like I said, if I was to develop it further into a bigger game, I would have used the red and green player enum as well. I didn't do it here for simplicity's sake. But yeah, that would allow me to remove SwiftUI entirely from my view model and similar. Anyway, inside the Z stack, after the V stack that goes on top of it, this is where we're going to say, here's our winner if we have one. So we'll say, if let winner be board.winner. If we have a winner, this is where we'll display who won. So we'll say there's a V stack, the text saying winner wins. A nice large title font like that. Then I'm going to add below that the button saying play again, which will reset the whole thing. So we'll say button action calling our board's reset method. The text saying play again with some padding and a background of blue and a clip shape of capsule like that. And remember, if you don't say otherwise, you'll have the default macOS button style. We don't want that here. I'm going to use a button style of plain, so it looks better. And then for the whole VStack, I'm going to add a little bit of spacing and color around it so it stands out more clearly against the board behind it. So I'll say this thing has a padding of 40 or so, quite big. A background of black with like a opacity of, I don't know, 0.85 or so. A little bit of transparency, not a lot, like that. Then we'll say there's a corner radius of 25 or so, just what looks good. And then a transition of scale. So it'll animate into location over time. And that completes our game. It should now be fully playable, all being well. I'll press Command R and give it a try. So I'll be green over here, then red's over here, and then I don't know, this way and similar. Oh, nice move from green there. This, and that go this way. This, boom, red's here, green's here, red's here. I'm going to try and end it fairly fast, folks. I'll do a bad move here. No moves to green, whoops. There, boom, red's almost dead. Come on, green die, or red die even. Boom, green wins. And hopefully, as we have green 93, red 0, if I press play again, boom, green 1, red 1. So it all resets correctly. And that completes the game, or at least as far as I'm going to do it in this live stream. That's been, gosh, almost 2 hours, folks. It's been quite a while. And so there are lots and lots of ways where this whole thing can be made better, quite frankly. If you want to take this game that you've either got locally or I'll put it on GitHub, and make it better, add more features and similar. You could say, maybe I want to have green in top left, red in bottom right, orange in top right, and blue in bottom left. I don't know. Different kinds of colors, have 4 players or 3 players. Wouldn't be hard to do. You could add a simple AI. So it's green as the player versus red as the AI. Gameplay kit, even though it's really, honestly, the worst API imaginable right now for Swift. It's all Objective-C, NS object monsters right now, sadly. It's still better than nothing. It has a min-max strategist built into it, which you could use for this to have a really good AI opposing you. You can add a menu screen. Welcome to BioBlitz and similar. Here's how the game works. So if you wanted to, you'd add an easy mode. Players could double click to turn left, for example, to have a little cheat mode or similar. You could add sound effects. You could add background music. You could add a background color. Oh, hello, dogs. Look, there's a whole bunch of treats waiting for you thanks to donations. Folks have donated money for you to have treats. Come on, good dogs. 1, 2. There is still time to donate, folks, by the way. Remember, this whole stream, my birthday, is being done in aid of folks experiencing homelessness. They get support from a local charity called Julian House, which is really, really a wonderful charity. And so it's homelessness and domestic abuse. Oh, another donation. Look at that, dogs. You're so lucky. You, lucky. Lucky. You're lucky you're cute, quite frankly. Yes, the whole thing is in aid of a charity. So thank you for donating for the dogs to have treats. It does go to a wonderful, wonderful cause. Anyway, if you have questions about the application or you want to give more dog treats, I can hang around a few more minutes. Otherwise, thank you so much for coming along. Thank you for all the very kind birthday wishes. And most importantly, thank you so much for all the donations. It really goes to a wonderful, wonderful cause. And they will absolutely appreciate it. It's really, really amazing to see. Thank you. Anyway, come on, dogs. You can say hello. Come on, up you go. Come on, say hello. 1, come on, up. Get up. Say hello. Yes, I'll upload the code. Oh, another donation. Goodness me. You too. You're so lucky. What? You're pushing me out the way, dogs. Oh, it's interesting. You think there's easy to tell about if they're being groomed, which is which. They've actually they trimmed Aria's paw fur. You never trim Sammy-Ed's main fur, but they groomed the bottom of the paw because she was finding it hard to get a grip because her fur's growing too long around her paw. She was slipping around on stuff too much. And she's now got basically manicured paws. It looks amazing. And that was one of the key ways they look different because Aria had these big sort of scruffy kind of paws and Luna always had manicured paws. Now they both have manicured paws. And they also gave Luna's face a clean so she looks snowy white like Aria does. They look more similar now than they ever have done. Dogs, there are still more treats for you here, but it requires more donations for folks towards Julian House. It's bit.ly/SwiftUI22. These hungry dogs need feeding. They need feeding. They're so hungry. Never get fed. Oh, poor dogs. Are you slobbering on me? You're slobbering on me, you monster. Dear me. Anyway, I think we're about done here, folks. Don't worry, the dogs do get fed very regularly. I'm going to have extra long walks tomorrow to walk off all these treats because they've had about 10 or 12 each, I think, so far, if not slightly more. Don't worry, they've enjoyed every single one. They may have wolfed them down very quickly, but they have definitely enjoyed them. Anyway, if you have any questions, I can hang around a few more minutes. Otherwise, I will see you online. Oh, yes, you like my photo. This is Bath Ales, by the way, another local company I appreciate. Not a charity, they're a company. They make good beer locally. Another donation. Okay, that's it, folks. Hakeem says, you get treats. Come on, good dogs. 1, other one. Yeah, you are good dogs. They love you so much. They really do. All right, folks, once again, thank you so much for coming along, and thank you so much for the donations. This stream will be online to watch tomorrow, next day, again and again and again. It'll be online for a long time yet. And again, I really appreciate you giving so much for an important cause. Until next time, folks, enjoy the rest of your day. I'm going to go and open some presents, hopefully, enjoy some birthday cake, and have the rest of the evening with my family. Take care, folks. Bye.